This is SpaceTime, Series 23, Episode 46, coming up on SpaceTime. The planet Venus dominated by atmospheric tidal waves. The X-37B Space Shuttle prepares for a new mission. And a test flight for China's new manned space capsule. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study shows Venus's atmosphere rotates much faster than the planet itself because of a thermal tide generated by solar heating on the planet's dayside and corresponding cooling on its nightside. The findings, reported in the journal Science, are the first to explain how the planet's super-rotating atmosphere is maintained. As well as being Earth's nearest planetary neighbour, Venus is also considered to be Earth's sister planet. See, they're both almost the same size with similar masses and diameter, and they were both formed in the same part of the solar system, therefore under similar conditions and out of the same materials. But if Venus is Earth's sister planet, then it's a twisted sister, with a runaway greenhouse effect that's turned it into the closest thing to hell in our solar system. Venus's surface is scorchingly hot, with an average temperature of around 462 degrees Celsius. That's hot enough to melt lead. And its crushingly thick carbon dioxide atmosphere is kept in place by a dense planet-wide cloud cover, resulting in surface pressures some 92 times greater than at sea level on Earth. Now that thick cloud cover does cause rain, but the rain on Venus isn't water, rather droplets of metal-eating sulfuric acid. Also, it snows on Venus's mountain peaks, but the snow isn't frozen water, it's metallic. Venus revolves very slowly on its axis, taking some 243 Earth days to complete a single rotation. Now that means a day on Venus lasts longer than a Venusian year, which is about 225 Earth days. Just as strange, Venus is the only planet in our solar system to spin backwards on its axis. That means the sun rises in the west and sets in the east. The new research, using data from the Japanese Aerospace Exploration Agency's Akatsuki spacecraft, shows that Venus's atmosphere rotates westward some 60 times faster than the planet's rotation. This fast-moving atmospheric tidal wave transports heat from the planet's equatorial dayside to its nightside, reducing temperature differences between the two hemispheres. The findings also show that this super-rotation increases with altitude, taking only 4 Earth days to circulate around the entire planet towards the top of the cloud cover. Closer to the poles, however, atmospheric turbulence and other kinds of waves have a more pronounced effect. The study's lead author, Takashi Horinashi from Hokkaido University, says that since Venus's super-rotation was discovered in the 1960s, the mechanism behind it has remained a long-standing mystery. Horinashi and colleagues made their discovery after developing a new method to track clouds and derive wind velocities from images provided by ultraviolet and infrared cameras aboard the Akatsuki spacecraft, which finally began orbiting Venus in December 2015, some 5 years after it was launched and accidentally placed in the wrong orbit. The new observations allowed the authors to estimate the contribution of atmospheric waves and turbulence to the superrotation. They found atmospheric temperature differences between low and high latitudes were small and couldn't be explained without including circulation across latitudes. The problem is that kind of circulation would change wind distribution and therefore weaken the superrotational peak. So that means there has to be another force, another mechanism, in order to reinforce and maintain the observed wind distribution. Further analysis revealed that the maintenance is sustained by the thermal tide, an atmospheric wave generated by temperature differences between the hot day side of the planet and the cooler night side. And it's this thermal tide which provides the acceleration at low latitudes. Earlier studies had proposed that atmospheric turbulence and waves other than thermal tide may have provided the acceleration. However, the current study shows that they actually work in the opposite to weakly decelerate the superrotation at low latitudes, even though they do play an important role at mid to high latitudes. So the new findings have uncovered the factors that maintain Venus's superrotation, while at the same time suggesting a dual circulation system that effectively transports heat across the globe, including the meridional circulation that slowly transports heat towards the poles from the equator, and the superrotation that more rapidly transports heat towards the planet's night side. These findings could also help astronomers better understand atmospheric systems on tidally locked planets, which when you think about it, isn't really all that different to what's happening on Venus, where its solar day is longer than its year. This is SpaceTime. Still to come, a new study has shown how high-speed gas collisions can suppress star formation along the central bar of barred spiral galaxies. And the X-37B Space Shuttle prepares for a new mission. All that and much more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, the Great Courses Plus. Learning about various perspectives can help make sense of the world as it changes every day. And the Great Courses Plus streaming service is an excellent resource to help expand your knowledge on a variety of subjects. You can gain valuable and reliable insights from some of the world's best teachers, helping us to better understand what's going on. And you will really love the way the courses are presented, plain, clear language that any level of learner can understand, and the presenters never talk down to you. It's all a fantastic way to keep your mind active while staying close to home. You can stream the Great Courses Plus to your TV and watch it as a family, or you can use the Great Courses Plus app to listen and learn while out in the garden, taking a walk around the neighbourhood, lockdown restrictions permitting of course, or simply while relaxing and taking it easy. Now, during these lockdown times, I've been taking the time to explore the full range of courses available. You know, I thought I knew this site pretty well, but I've got to say the variety and depth of knowledge available through the Great Courses Plus really is quite staggering. Now, naturally, I started in the science section, and there's plenty there to keep most inquiring minds buzzing for weeks, if not months. Now, one course I checked out that I really need to recommend to you is one in the social sciences section. It's called Understanding the Misconceptions of Science. This course is a great conversation starter and argument settler. For example, it takes an in-depth look at Benjamin Franklin and his famous kite. I mean, did it really happen that way? I won't give away the answer, you'll need to check that out through the course. But it's not all science on the Great Courses Plus. It doesn't matter what your family members are into, I'm pretty sure you'll find a course to suit them. And to get you started, we have a special offer. By signing up to the Great Courses Plus, we're offering SpaceTime listeners a free trial with unlimited access to the entire Great Courses Plus library. So you can go and explore just like I've been doing. All you need to do is sign up today to our special URL to start your free trial. So go now to thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space to start your free trial. And of course, you'll find those URL details in the show notes and on our website. That's thegreatcoursesplus.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
A new study claims high-speed gas collisions are suppressing star formation along the central bars of barred spiral galaxies. The findings, reported in the monthly notices of the Royal Astronomical Society, could help explain why the spectacular barred spiral galaxy NGC 1300 isn't sparkling with new stars along its central bar structure. NGC 1300 is located about 68 million light-years away in the constellation Eridanus. The spectacular arms of spiral galaxies shine blue because they're loaded with hot, bright young stars. But the galactic bulges at the centres of spiral galaxies often look a lot redder. That's because they've got lots of older stars in them, and they're not producing quite as many hot young new stars, despite containing lots of raw material. This characteristic's especially noticeable in barred spiral galaxies like NGC 1300. And it's worth pointing out that our own galaxy, the Milky Way, is also a barred spiral, although its central bar is only about 2/3 the length of NGC 1300. To determine why NGC 1300's central bar isn't producing stars at higher rates, astronomers use computer modelling to simulate the movement of molecular gas and dust clouds around the galaxy's central region. Low-speed collisions among these molecular gas and dust clouds are known to cause the clouds to collapse and trigger star birth. However, what the simulations showed was that the clouds around the heart of NGC 1300 are colliding at speeds tens of kilometres per second faster than elsewhere. So quickly, in fact, that the turbulence generated is preventing the clouds from collapsing down to form new stars. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
Let's talk about this weird galaxy that's having trouble breeding. This is NGC 1300, I'm guessing, just off the top of my head. What's going on with it?
It is having trouble breeding here and there. Put it that way. And let me preface this little segment with the fact that galaxies do come in all kinds of different models and different types, and there are galaxies where there really is no star formation taking place. They're old galaxies, and the reason why there's no star formation is because they've used up all the hydrogen gas that is the raw material for making stars. Our own galaxy, we can see from our view from the inside. Of course, we're in the disk of our own Milky Way galaxy, but we can see star formation taking place. There are many places. You've only to think of the Pillars of Creation, that famous Hubble image of the three towering dust clouds. That's one of the galactic regions where star formation is taking place. But it's not the case with all galaxies. Now, the one we're talking about, NGC 1300, I'm very glad you mentioned that one because it's the perfect example of what's going on with this. It is a spiral galaxy, which means it's similar in structure to our own. It's got a central nucleus and beautiful spiral arms. Sadly, we'll never see the spiral arms of our own galaxy from the outside because it's just too big. But we can see other galaxies. The spiral arms of spiral galaxies, we know, are places where star formation is taking place. Because what we see is, if you look at a galaxy and you're not looking at the individual stuff in it, you're just looking at the whole galaxy. What you see is the spiral arms are predominantly blue in colour. And that comes from hot, young, vigorous, virile stars, which sort of live fast and die young. They're very massive stars, bigger than the sun. They burn their hydrogen at a phenomenal rate. Their temperature is very high, and that's what makes them blue. So that is very typical of what you get in an active star-forming region. You get smaller ones as well, smaller, cooler stars, but it's the supergiant stars, the blue ones that really show up the spiral arms of a galaxy. And anybody who feels like actually bringing up an image of NGC 1300, there is a beautiful Hubble telescope image. It's absolutely stunning. You can see that its spiral arms have lots of blue blobs in. There are pink blobs as well. Pink is excited hydrogen, which, just like humans, glows pink when it gets excited, but for different reasons. You can see the pink blobs. You can see the blue stars. That's all symptomatic of active star formation. However, and this is the bit where this particular galaxy, and it's by no means alone in this, Andrew, there are many galaxies of this class, the place where it breaks down, because NGC 1300 is what is called a barred spiral galaxy, B-A-R-R-E-D. It has a bar, not one you can lean against, but essentially a linear feature in its center. So if you imagine a sort of a bulge in the middle of the galaxy and then sort of straight arms coming out either side of the bulge, which is this bar-like feature. And from the ends of that bar, that's where the spiral arms join on. And so
I see it. Yeah. Yes, I'm looking at that Hubble photo now.
Yeah, that's good.
A damn fine photograph.
It's an extraordinary photograph. Yeah, wonderful. So that's all good. But what has always been a puzzle with barred spiral galaxies is that the bar itself is very rich in the raw material of stars, namely hydrogen. There are clouds of hydrogen all over the place in the bar. But you can see just by looking at it that bar is sort of almost orangish in colour. It's a yellowish colour.
It is,
rather than blue. And that tells you that what you're seeing is predominantly old stars. You're not seeing these vigorously shining blue stars. So even though you've got the raw material there to make new stars, you're not seeing them. You're just seeing a population of old stars, which are kind of tired.
It's a galactic nursing home.
Indeed it is. But it's a galactic nursing home surrounded by, everything that you would need to make it a galactic nursery.
Well, in that case, what we're looking at is a COVID-19 galaxy because all the old people are stuck inside and the young people are outside looking through the windows.
Yes, and not able to do anything. That's right. Okay, so this is what this research is about. That's the backstory. And the news is that researchers, based predominantly, I think, in the United States, yes, the Carnegie Institution in Washington, they have figured out why there is this conundrum of no new stars forming in an environment that is rich in the raw material for new stars. And it turns out that in the bar of a galaxy, a barred spiral galaxy, the motions of objects within that are really quite high, much higher than you would expect in a more sedate region like the spiral arms. And so these astronomers have essentially looked at the motions of gas clouds within the bar of the galaxy and realized that they're charging around too quickly for a given gas cloud to sort of settle down and collapse under its own mass, under its own weight, and form stars. That's how star formation works. You've got a cloud of gas, pulls itself together under its own gravity, and as it collapses, it's compressed, the gas is compressed, the temperature goes up, eventually it's high enough for nuclear processes to start, and you've got a star. The gas clouds in the center of the bar of NGC 1300, plus many other barred spirals, they're too busy whizzing past each other and gravitationally disturbing each other. So you don't get that nice, calm, quiet, reflective settling down of the gas cloud to collapse under its own gravity and form a star, which is a very, I think that's a really nice piece of work. And
so essentially, it's just too active. It's just there's too much going on for it to settle down into the star formation formula.
Exactly. Too much of a swirl of material. You've got a gas cloud that thinks, I'll just start collapsing under gravity here. And another one whizzes by and basically gravitationally disturbs it so that the gravitational collapse doesn't happen. There are lessons in this, Andrew, for our own galaxy, because we do know, even though we can't see it from the outside, we do know that our galaxy actually has a bar as well in the center. And it comes about because, once again, it's the velocities of stars that we can measure towards the galactic center. This is work that I've been involved with some of the star surveys that I've been mixed up with. So the bar is a real feature in our own galaxy. I don't think it will be anything like as prominent as the one that you're looking at in NGC 1300, but it is still, it's probably about a third as long as that bar. So a less emphatic bar, if I can put it that way, but nevertheless, a barred spiral galaxy.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is SpaceTime. I'm Stuart Gary. Still to come, the X-37B Space Shuttle prepares for another mission, and China conducts its first test flight of its new manned space capsule, with things not necessarily going to plan. All that and more still to come on SpaceTime. The United States Space Force is about to launch one of its X-37B Space Shuttles back into orbit. The classified OTV-6 mission is slated to fly on May the 16th aboard a United Launch Alliance Atlas V rocket from Space Launch Complex 41 at the Cape Canaveral Air Force Station in Florida. The upcoming launch is being seen as an important mission, hosting more science payloads than any previous X-37B flight. Included in the manifest is an experiment designed by the US Naval Research Laboratory to convert solar energy into radio frequency microwave energy and then transmit that energy down to Earth. Tesla would have been impressed. The mission will also deploy the US Air Force Academy Falcon Sat-8 research satellite, which is carrying some 5 scientific payloads. The mission will also be the first time the X-37B has carried a service module in order to expand its capacity. 2 NASA experiments are also aboard the mission, one looking at the effects of space radiation on seeds, while the other will assess the performance of various materials in the space environment. And those 2 experiments alone suggest that this will be another long-duration flight for the X-37B. But then again, that's not unexpected. After all, its last mission, which ended in October last year, lasted some 780 days. Collectively, the Air Force's 2 X-37B spacecraft have flown 5 missions, totaling a combined 2,865 days in orbit. Of course, pretty well everything they're doing up there is classified, so we don't really know what they're up to. Back in 2014, security experts claimed the X-37B was being used to test new generation reconnaissance and spy sensors to see how they survive long-duration spaceflight. Then in 2016, there was speculation that the X-37B was testing a new version of a joint British-Boeing EM drive, an electromagnetic microwave thruster. Meanwhile, the US Air Force has confirmed that in the past, the X-37B's tested a Hall-effect thruster system for Aerojet Rocketdyne. The X-37 is a small reusable spaceplane originally built by Boeing in 1999 as the X-37A to be launched from the payload bay of NASA's Space Shuttle. However, the project was transferred to the US Department of Defense in 2004. The aerodynamic design of the X-37 is based on that of the Space Shuttle. Its specifications include a delta-V, allowing it to undertake significant orbital maneuvering, including deploying satellites into orbit other than the one it was actually set up into, and rendezvousing with other spacecraft in orbit to perform repairs or modifications, or even to retrieve satellites for return to Earth. In 2006, the US Air Force announced plans to develop an updated version called the X-37B. Two were built, the first undertaking its maiden flight in April 2010. The upcoming mission will be the sixth launch of an X-37B. This is SpaceTime. Still to come, China test flies its new manned space capsule, and later in the science report, nasal swabs are found to have higher concentrations of COVID-19 virus than throat swabs, and claims coins might be better than notes for paying cash without spreading disease. All that and more still to come on SpaceTime. China claims it successfully launched a new prototype capsule, which would eventually be used to fly crew to Beijing's planned space station and eventually onto the moon. China's state-run Xinhua news agency says the new spacecraft was launched aboard a Long March 5B rocket from the Wenchang Satellite Launch Center on the southern Chinese island of Henan. Xinhua says the new capsule will eventually replace the current three-person Russian Soyuz-based Shenzhou manned spacecraft. The as-yet unnamed new spacecraft will be capable of transporting up to 6 Taikonauts, or 3 Taikonauts and 500 kilograms of cargo, to China's new space station. And according to Xinhua, it'll eventually also be used to fly crews to the moon by the end of the decade. The unmanned test flight placed the capsule into a low Earth orbit of around 400 kilometers. It then relit its service module main engine to increase the altitude to around 8,000 kilometers, in the process demonstrating some 1.9 kilometers per second of delta-V, the sort of power needed to get to the moon. The 20-ton capsule also trialled a new detachable heat shield, evidence that the new capsule is being designed to be reused. Also under trial was a flexible inflatable cargo return module, basically a low-density supersonic decelerator with its own inflatable heat shield. However, it turns out the decelerator experienced an anomaly during its re-entry, and in case you're wondering, that is a euphemism for crash and burn. The mission was also the fourth launch and the third successful flight for the 54-metre-tall Long March 5 rocket, and it follows a string of recent failures involving Long March 3B and Long March 7 rockets over the past few months. The mission was an important step in China's plans to launch the first modules of its Tiangong or Heavenly Palace space station in 2022. Eventually, the space station will have 3 modules, not as big as the International Space Station, but it will provide Beijing with its own independent perch in orbit. The flight also comes as the Communist government tries to deflect attention away from global criticism over its actions in trying to cover up its failures over the COVID-19 coronavirus pandemic, and new allegations that Beijing's violated its anti-nuclear test ban treaty agreements by conducting a series of secret low-yield nuclear bomb tests. A report by the US State Department found China may be flouting international law by conducting the tests in newly built explosive containment chambers at its Lop Nor nuclear site in the country's remote northwest. This is SpaceTime. Still to come, the science report, and a new study showing that nasal swabs have far higher concentrations of COVID-19 than throat swabs, and claims starting school an hour later may help high school kids get a better night's sleep. All that and more still to come on SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study claims nasal swabs have been found to have far higher concentrations of the COVID-19 virus than throat swabs. A report in the journal Nature says the sites appear to be novel coronavirus hotspots. Researchers found genes associated with how the virus enters a host were found in a number of mucus-producing nasal cells. The researchers say it suggests that nasal cells are the site of the original viral infection, and possibly also the source for spreading the virus. Meanwhile, Italian scientists have brought together all the available evidence they have on COVID-19 in children and adolescents. The findings, reported in the Journal of the American Medical Association, are based on 18 studies with a total of 1,065 participants. The research found the most common symptoms in young people was fever, a dry cough, and fatigue. But many kids remain completely asymptomatic. Scientists did identify one infant with pneumonia who was successfully treated in intensive care. No children younger than 9 died of COVID-19, and most children with the virus only suffered very mild symptoms, if any. The authors say it seems kids typically have a good prognosis, usually recover within a fortnight. A new study claims that coins may be a better option than notes when it comes to paying cash without spreading bacteria. A report by the European Congress on Clinical Microbiology and Infectious Diseases found that 24 hours after being exposed to bacteria, coins containing copper showed antimicrobial activity, with levels of bacteria dropping by as much as 99%. Now, in contrast, the number of bacterial cells found on banknotes were not reduced compared to the control. The study points out that although coins did cut bacterial levels, not all bacteria were eliminated, so they can still spread disease. Of course, it's worth remembering that COVID-19 is a virus, not a bacteria. Well, this is something I dreamed of when I was at school. Now, a new study has found that starting school an hour later may well help high school kids get a better night's rest. A report in the Journal of the American Medical Association claims a delay of between 50 and 65 minutes to the start of school allowed teens to sleep an average of 43 minutes longer on school nights, compared to those who had to go to school early. Now, the authors note that teens who had a later start didn't necessarily go to bed any later than the early starters, but they tended not to need as much catch-up sleep over the weekend. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.